Unit 10, Day 2, Notes, Point Slope Form. Okay, so before we really get into this, I want to just kind of take you back just a little bit. Okay, we've been dealing with slope-intercept form for a long time, right? Okay, y equals mx plus b. Now, what are the two things that form actually gives you? Not everybody say it at once. It gives you the slope and the y-intercept. The slope and the y-intercept form is really what it is. It tells you those two things, slope and the y-intercept, right? Just right there, it's staring at you. Okay, so given that information, what do you think the point slope form tells you? Again, pretty obvious. These things are not named in a tricky way. Okay, it gives you a point and the slope. Is the slope the m right there? The point is this x1, y1 part of this. Okay, so here's point slope form. Okay, is y minus y1 equals m times x minus x1, where x1, y1 is a given point on the line, and m is the slope of the line. Okay, so given a point and the slope, write the equation of the line. Okay, so for now, we're not really going to do a whole lot with this. We will next page, but for now, all we're going to do is we want to write it like this. Okay, so if I have my point, I'm going to call it x1, y1. X always comes first. And so I get y minus y1 equals m times x minus x1. So y minus 5 equals negative 2, parentheses, x minus 3. Okay, y minus 5 equals negative 2, parentheses, x minus 3, close parentheses. That's it. That's all I'm doing. Okay? Just replacing each of these unknowns here, y1, x1, m, with what we do now. All right, easy enough. Let's look at 2. We have x1, y1, and m right there. All right, so I'm going to write this. Y minus y1 equals m x minus x1. By the way, this form right here comes from the slope formula. Okay, so if you remember that, okay, that's really where it comes from. So no big deal. You don't have to know that necessarily, but you can probably pretty easily see where it comes from if you rearrange this a little bit. Okay, so y minus y1. Well, now there's already a minus sign there. So I'm going to put in a minus a negative 6 equals m positive 2 times x minus a negative 5. Okay, well, if I have minus a negative, grab my pen here. If I have minus a negative, that's going to turn into addition, right? So subtracting a negative, same as adding a positive. Same thing over here. So I could write that as y plus 6 equals 2, parentheses, x plus 5. Okay, good so far? The whole point. So stop me, pause the video. If you have questions, write them down and ask me. Okay. So this, our same sort of idea here. We're going to have to watch the negatives really, really carefully. I never made that full screen. But watch the negatives really, really carefully, okay? Because if you're given a negative, since you already have this minus sign automatically, you already have the minus sign, it may just end up being a double negative and making it a positive force. Okay, grab all my pens just in case. I want to do some colors in a minute. Okay, number 3. I'm going to label my point x1, y1. I have m already. Now I have y minus y1 equals m times x minus x1. I wrote that one a little early. Minus x1. So y minus 2, so 2, equals m times x minus, x1 is a negative 7. So minus a negative 7, which turns that one into a plus 7. So y minus 2 equals 3 times x plus 7. Okay. All right. I'm going to go ahead and write the equation down here. Okay, now I'm going to end up plugging some things in. Minus equals something, which is our m, times x minus something else. Okay, so I have x1, y1, and our m. All right, so our m, -1, goes right in there. X1 is 4, and our y1 is -3. Okay. Do I have any double negative situations here? Matter of fact, yes. This right here turns to double negatives. 2 negatives make a positive, so y plus 3 equals -1, x minus 4. And there we've got it. Okay, number 5. X1, y1, m. All right, so when I write this out, I'm going to have y minus y1, which let's see, I did that one in purple, equals m times x minus x1, which is 8. Okay, so now you may notice this already, that having that -0 right there really isn't necessary. So we can write y equals 1/2 x minus 8. And there's all we're going to have for now. Okay. Number 6. X1, y1, m. All right, so I'm going to write y minus, or no, yeah, you want to go with that first. Y minus y1, which I use purple for. So y minus -2 equals m times x minus x1, which in this case is -2. Any double negatives we have here? Matter of fact, yes, both these. Anytime we have a negative in our point, we actually end up with a double negative in our equation. So we get y plus 2 equals 1/4 times x plus 2. Oh dear, I got a point mixed up, didn't I? I did. It's right here. X1, something just didn't look, I just see that and I feel it in my bones. Something's not right. Okay, so x1 is actually -4. So this is a -4, which means it is a +4 right here. Still have the double negative going on. But if we have negatives up here, we end up with positive down in our equation. Okay. Now, if you notice, we have our two special cases once again. M is 0, M is undefined. Okay, so our Hoy-Vux is really where this is coming back in handy again. Hoy-Vux. Okay, so if we have a slope of 0, then we get a y equals something or other. Graphically horizontal. So we get y equals, what's the y in this problem? Well, it's 9. Okay, so that's kind of how I see it. Now I want to go and do this with the point slope. Okay, y minus y1 equals m times x minus x1. Okay, y minus y1 in this case is 9 equals m 0 x minus 1. Well, notice this, 0 times anything is what? It's always 0, right? So all this really cancels out. And we end up with y minus 9 equals 0 if we were to keep going. Okay, now you could just leave it, for now you could leave it right this way. But if we add 9 to both sides, we get y equals 9. That's not magic, that's not convenient. It's just not a coincidence, that's just the way it is. So that these two actually work out the same. Now, I recognize it right there immediately. I can save myself a little bit of work there. Okay, I like doing that. Okay, number 8, we have an undefined slope. All right, continuing where we left off, we have new directions. Write the equation of the line in slope-intercept form. Okay, so we're given the point 3, 4, and m equals -2. So I'm just going to kind of rush through this part. Okay, writing it in point-slope form. Y minus, let's see, x1, y1, y minus 4 equals -2m times x minus 3. Okay, hopefully we feel pretty comfortable with that right now. Okay, now this is write it in slope-intercept form. That means our end result for all of these is going to be y equals mx plus b. This is not in y equals mx plus b form. Okay, there are two things we have to do. There are two things we have to do to get it in that form. Hi, apparently my picture wasn't there yet. All right, two things we have to do. First thing is distributing. Okay, we need to distribute. So I'm going to take -2 times everything in those parentheses. So we'll get -2x, and then negative times negative is positive, so we get +6. Remember I said y by itself, watch out for your negatives again. Okay, and so we carry down y minus 4. Okay, so next we need to now that we distribute, we want y by itself. Is y by itself? No, it isn't. Okay, we need to take y right there and box it in, and we need to add 4. We need to use the opposites. Add 4 to both sides. And so we get y equals, since that's a 0 pair, -2x plus 10. Okay. Now, there's really not a great way to check this except for one thing. When we graph this, it needs to go through that point, 3, 4, and have a slope of -2. That's our check. So over in my graph, I'm going to start at 0, 0, positive 10. 0, positive 10. Just use over here. 0, 10. It's a -2 slope, so it's going to go down 2 and over 1. Down 2 and over 1. Down 2 and over 1. Down 2 over 1. And we actually have tons of room to do this. Oh, I skipped a point there. And so it goes right through here. Okay, now the only question is, two questions, I guess. Does it have a slope of -2? Down 2 over 1, down 2 over 1, definitely. Okay, but does it go through the point 3, 4? Okay, so the point 3, 4, it's right there. So yes, it does. And so we know that this checks out. Okay, number 10. Again, we'll go to point slope form. So y, and I kind of see what's going to happen, so I'm going to go ahead and write this. Y minus -4 equals m times x minus x1. So it's going to be y plus 4 equals 3 times x minus 1. Okay, so I saw that coming because anytime you have a negative over here, you end up with a plus over here. Positive over there. Okay, so we need to distribute in order to get it closer to y equals mx plus b. We distribute. So we get 3x minus 3. And bring down our y plus 4. Is y by itself? Just like before. We're almost always going to have a number over here that we need to deal with. Okay, so we'll need to subtract 4 from both sides. Okay, and so these two combine nicely. They do go together. They're not oil and water sort of thing. They really do. You can put them together and stay together. So we get 3x minus 7 and a y up here because those two form a 0 pair. So y equals 3x minus 7. Now this is a positive 3 slope. So it's going to go up 3 and over 1. So we're going to start at -7, 0, -7. And it's going to go up 3, 1, 2, 3, over 1. 3 over 1, 2, 3 over 1 over 1, etc. Okay. Now we really want to know if it goes through this point 1, negative 4. So the point 1, negative 4. Is it going to go through that? Yes, in fact, it goes exactly through that. Okay, so that equation matches what we were told originally. It does have a slope of 3. It does go through the point 1, negative 4. Okay. Let's go on to number 11. Okay. Again, if we go to point slope form, y plus 1, oops, x1, y1, y plus 1, because that's y minus a negative 1, equals m times x minus x1. In this case, it's a minus a negative 2, so it will be a plus 2 right there. All right, so there it is in point slope. Now, I said this earlier, but I think I did. The beauty of this is that really, if you know the point and the slope, you can go straight to this formula right here, this form right here. If you happen to know the slope and the y-intercept, you can go straight to this one. Okay, so you can actually go between the two. That's kind of the beauty of it. So it may take a little bit of work to go from one to the other, but you can do it, and it's kind of useful for that. So depending on what you know, one may be better than the other to have. So let's go through the same process, distribute. Okay, so we'll get negative 4 times x, or just negative 4x. Negative 4 times 2, that's a negative 8. Y plus 1. Okay, is y by itself? Nope, it never is. So we have to subtract 1 from both sides in this case. Okay, and these two go together, so that's a 0 pair. These two go together, so we get negative 4x minus 9. Okay, so when we graph this, we'll start at negative 9, 0, negative 9. And it's a negative 4 slope, which means it's going to go down 4 into the right one, or up 4 into the left one. So down 4, no, that's not going to work. Okay, so we're going to have to go the other way. So we're going to go up 4 to the left one, 4 to the left one, up 4 to the left one, etc. The question is it going to go through negative 2, negative 1? Negative 2, negative 1. It's that point right there. So yes, it does. Okay. So there we have it. Our line is the same slope as we started with, and it goes through the point negative 2, negative 1, which the equation said it would. Okay. All right, 3 more of this kind, and then you can show me what you know. Okay, going straight to the point slope, y minus 3 equals m times x minus, no, plus 8, because it's x minus a negative 8. Okay. From our point slope. Okay, so we need to first distribute, as we have every time here. A half times x, well, it's just a half times x, so nothing really we can do there. A half times 8, however, we can work out, and that's just 4, so positive 4. Bring down y minus 3. Y is almost never by itself, so we will have to do the opposite here. We have a minus 3, so we're going to have to add 3. Remember, we add once on each side. Okay, so these two cancel out. These two go together. So we get 1/2 x plus 7. One half x minus plus 7. All right, so we'll plot this point. We'll start at 0, 7. 0, 7. Okay, now it's 1/2. which means it goes up 1 and to the right 2, or down 1 to the left 2. Up 1 and over 2, up 1 and over 2, 1 and over 2. Not to be confused with 2 over 1. Okay, there we go. Yeah, or down 1 to the left 2, down 1 to the left 2, left 2. Okay. I probably shouldn't have drawn my line all the way because I want to make sure it goes through that point, -8, 3. So in my graph, I go -8, up 1, 2, 3. There it is. It goes right through that point, so I know that this line actually works. It has the same slope. All these are the same. This one goes through -3, 8, or -8, 3, and this line goes to -8, 3, so I know it works. Okay, number 13. We have our special case. These last two are our special cases. These should go pretty quick. Okay, so point-slope form. Okay, so this is, we have slope of 0. Oh, wait a second. So y minus -3. So I get plus 3 equals m times x minus x1, which is 2. Okay, now if I take this right here, and I distribute this, 0 times x is actually 0. 0 times -2, 0 times anything is 0. So all this really turns into just 0. So y plus 3, bring that down still, equals 0. It's y by itself. I said it almost never is. Subtract 3 from both sides. Can I put a 0 and a -3 together? Does either one of them have a variable? No. So I can put these two together. So 0 minus 3 is -3. So I get y equals -3. Now I want to draw your attention back to Hoy-Vux. Okay, this is a y equals line, right? This is a y equals line. So it has a 0 slope, which lo and behold, it does right here. And it's a horizontal line. So it's going to be a horizontal line that goes through -3. So y equals -3 right down here. In fact, that point to -3, does it go through that? To -3. It does. 0 slope, horizontal line goes right through there. Got it? Okay. Watch out for these special cases. Okay. Number 14. Last one for the day. I believe. Yep, last one for the day. Okay. Now, this is before I even go into point slope and all that. There is something very, very strange about this one, different from all the rest. And that is the slope is undefined. Okay. So looking back at the Vux part of this, if you have an undefined slope, your line's going to be an x equals, and it's going to be a vertical line. Well, this makes for some really strange things that happen. So we actually cannot put this in point slope. We actually can't put it in SlopeIntercept form. It's just going to be x equals. And what is the x in this problem? There's only one that we've got. x1, y1. What's the x? -3. So x equals -3. Okay, so I'm going to go over to my graph and put down that point. -3, 0. It's going to be a vertical line that goes through that. So it's going to go straight up and down. And that is the end of that special case. So I want to just remind you of the two big things I point out every day for this unit. Get y by itself. Make sure you have y by itself. Sometimes it may take a little bit of work, but you got to watch out for that. And watch out for your negatives. Okay? So keep those two things in mind as we go and do our assignment. Let's get this.